Hi there, Erasmo here. Welcome to the second video with your humble servant. I'd be very grateful if you could share in the comments how you're enjoying the new speaker. Our director is still on the fence about who's cooler, me or the old human voice. Thank you in advance. So far we've covered around 20 videos about ALP, and I think it's time to dive into connecting signals to analog inputs. Let's assume we need to connect a thermistor to the input of a PR. I'll demonstrate this process using the PR200 as it involves a few extra steps and details. For other PR models with analog inputs, the process is simpler. You can specify the required signal type directly in ALP. For the PR200, the first step is to physically configure the analog input for the desired signal type. This involves setting the jumpers on the device's board correctly. To access them, we'll first remove the terminal blocks and then take off the device's top cover. To get a better view of the jumpers, I'll remove the upper board which holds the device's display. Now you can clearly see the jumpers. Removing the upper board isn't always necessary to reposition the jumpers, but it can make the task easier. The jumpers are quite small, and adjusting them with the upper board in place can be tricky. That said, with some skill and patience, it's still possible to manage without removing it. The board provides clear instructions for setting jumpers for different signal types, including 0 to 10 volts, 4 to 20 milliamps, resistive signals from 0 to 4 kilo ohms, and digital input mode. By default, the jumper is configured for 4 to 20 milliamp signals. Since we'll be connecting a thermistor, we will adjust the analog input to support a resistive signal. Now set the jumpers as shown in the diagram on the board. Next, reassemble the device in reverse order. Carefully install the upper board, ensuring you don't bend the pins it connects to. Then, put the top cover back in place and reattach the terminal blocks where we'll connect the wires. Now let's connect the sensor to the configured analog input. If you're unsure how to connect the sensor, don't worry. The connection diagram is, as always, available on our website or in the PR user manual. For your convenience, I'll include a QR code here linking directly to the PR200 page. Now it's time to switch to ALP. Create a new project for the PR200 and navigate to the section with the relevant analog input. In the input properties, you can define the mode for this input, analog or digital, as well as the type of connected signal. By default, it's set to 4 to 20 milliamps. But since we're connecting a thermistor, we'll change it to 0 to 4 kilo ohms. Additionally, you can configure the filter time constant in the analog input properties to smooth out the input signal. At this point, the contact extending from the analog input provides the measured signal in ohms, representing the sensor's current resistance. However, we want to work with the measured temperature in degrees. To achieve this, we need to convert the resistance into temperature. The easiest way to do this is by using a pre-made macro from the component manager, which I mentioned in the previous video. A quick disclaimer. To use the component manager, you'll need an active internet connection. Once connected, navigate to the Analog Conversions tab in the online macro database and find the sensor type you need, such as the PT1000 sensor. Check the box next to the desired macro and click Upload the project library to add it to your project. Once you close the online database, you'll find the macro named PT1000 in your project's component library. Drag it into the workspace, connect the state of the analog input to the macro's input, and you'll get the measured temperature at the output. If your sensor type isn't listed in the component library today, don't worry. We add new types every month. Have a specific request? Let us know in the comments or via our support email. These online macros also account for the resistance of the wire connecting the sensor, and generate an error code if the measured signal exceeds acceptable limits. If you prefer, you can create a custom macro to handle these tasks yourself. By the way, if you're using 4 to 20 milliamps or 0 to 10 volt signals, you can easily convert them to the desired range directly within the analog input properties. There are two parameters for this, the lower measurement limit and the upper measurement limit. By default, these are set to 0 and 1 respectively. For example, if you are measuring pressure in the range of 1 to 5 bars and converting it to a normalized 4 to 20 milliamps signal to send to the PR, you can use the analog input settings to convert this 4 to 20 milliamps signal back into bars. In this case, the lower limit will be set to 1 and the upper limit to 5. This allows you to decode the current signal back to its original value. For the PRM expansion modules and other PR controllers, the sensor type connected to the analog input is configured directly in ALP, with no need for jumpers on the boards. This is done in the analog input properties in the sensor type setting. Here, in addition to standard voltage, current, or resistance signals, you can directly select the type of thermistor or thermocouple connected to this input. If you do this, there's no need for a macro to convert resistance to temperature. The output of this analog input will already be displayed in degrees. Let's also take a look at how this is done in the PR102 settings. In general, the procedure is identical, with the only difference being the location of this parameter. Once you configured the analog input, you can use the data in your program, display it on screens, send it over the network. In short, apply everything we've learned so far. In the next video, we'll explore how to work with analog outputs. In the meantime, don't forget to subscribe to our channel for updates on this and other courses. If you found this video helpful, give it a like, and feel free to leave a comment. We'd love to hear your thoughts, or answer any questions you might have. See you next time.